Thank you so much for being here on time. We have a very special guest this afternoon from the MRC, Mr. Leonard Gentle. So he'll tell you a little bit about his history and how he came to the MRC, but he's a retired school teacher and he now consults on community engagement for the MRC. So please help me in welcoming Mr. Gentle to our division.
Firstly, can I just stand here and talk? Can everybody at the back hear me?
Yes.
I don't need microphones or anything like that. Okay, thank you. All right. This is one of those things that was passed on to me. Somebody else in the MRC passed my name on. And I don't say that by way of apology, because what I've been asked to do at the MRC is to do, its official title is called Research Translation. But I'm a bit of a critic of this idea of research is done by some people who know what they're doing, and then it's translated to largely ignorant people who don't know what the wise people are doing. And you know, I find that process a little bit problematic. So I suppose the reason why I was asked to is I then spoke at length to the MRC people who are scientists in their own way, and this is the outcome. Now, my own background is many years ago as an electrical engineer, but I'm embarrassed to even say that because I know absolutely nothing to do with electricity or engineering. I can't fix a plug, so that's part of a dark past. But then for many years I worked as a science teacher, and then I became a trade union organizer. And what I discovered in that world is that firstly, people have an enormous interest in the broader world. It's some sort of myth that people just get on with their lives and they don't want to know the big important things. And after that experience, I spent many years heading up a non-government organization which largely took economic theories and tried to unpack them so that ordinary people could understand them. So that's my background. So when I was contacted, I sort of took a provocative stance, and I entitled this The Politics of Research and the Battle for Public Opinion. And then the lady who escorted me here said, you know, the issue of community engagement is very close to the hearts of everybody here. So I partly kind of constructed a discussion on that big question of politics of science. And I'm going to amend it a little bit to tailor it for what I understand to be your needs. Now, by way of conclusion, I'm going to state this, that the process of engaging the public is not an add-on. It's not something that is a distraction from the main purpose of what science is all about. That both the actual practice of real science as well as the actual practice of being an informed member of the community are not separated things. And so I'm going to first of all try and engage this idea that science is a precise, exact thing that merely involves people digging in their heads and producing evidence which somehow stands on its own. So for a few minutes I'm going to dwell on that, and then I'm going to reflect on the other side, why the issue of public opinion actually matters for scientists and for the public. Now, this idea that science is a lonely process of examining the evidence and then drawing conclusion doesn't stand up to historical scrutiny. Firstly, scientists have for many centuries often served purposes that were associated with the doctrines of the church, with powerful dynasties, in more modern times with very right-wing regimes. And the scientist's role was, in a sense, to add color to prejudices that existed in the political arena. And I suppose if this is the Department of Human Genetics and so on, then probably no other discipline has been more absorbed into ideas of social Darwinism, that somehow white people are superior because naturally the fact that they rule everywhere means that the process of natural selection must have played itself out, and therefore the science confirms why the power relations in the world look the way they are. In other words, science becomes an adjunct of a political project of domination. Now that's very well known. And we tend to think of that as something in the very distant past, in the 19th century in particular. But we're seeing in this era of Donald Trump and so on, a revival of what I call race theories. Ideas that certain human beings have a predilection for certain illnesses. And in the MRC, which was founded in 1968 as a then apartheid institution, they very much proclaimed race theory. And in its earlier incarnations, looked at issues such as TB, but didn't ask the questions of the prevalence of TB in certain communities on the basis of their socio-economic condition, absence of clean water, poor housing, overcrowding, etc. But saw it as a race issue, that certain races had a genetic predisposition to either acquire TB or not have the ability to confine it to the parts of the body where the TB bacteria are harmless. So in other words, scientists then acted according to the dominant political norms of the day and did good science, but it presumed a paradigm which says that there's some correlation between the phenotype, the external, and a genetic predisposition. And that's been revived. In the US today, there are many scientists, etc., who are once again reopening that debate about questions of the sort of scientific predilection of certain human behaviors. There's a branch of science, I call it a pseudoscience, called social biology, who began to contemplate that maybe there's such a thing as a gay gene, that you could isolate a gay gene and then the promises of sort of genomic medicine could cure people in advance or cure fetuses or organisms before the gay gene sort of wreaked its havoc on the human being in the mature stage. So it's a field very much informed and impregnated, as you like, if you like, by the politics of the day. Now, sometimes it's easy for us to, and I mean, I sound a bit smug because it's easy to say, we can dismiss that. Nothing to do with us. But there's another part of this, what I would call the kind of co-option of science in the services of elite, which is probably even worse than social Darwinism or the notion of gay gene. And it's the idea that we now live in a time where all the human problems and environmental problems will be solved through technological innovations. By now you must have heard, and I'm a complete cynic about this term, that there's something called the fourth industrial revolution, which is being peddled by the World Economic Forum. And it presumes that technological innovations would solve, precisely at the time when we're confronted with the crisis of global warming, and the possibility that if we keep producing greenhouse gases and industrial output at the rate at which we are, the world stands very little chance of survival. And yet, in the middle of that narrative, we have a scientist narrative which peddles this idea that there's a new industrial revolution of artificial intelligence and nanotechnologies, etc. And if you want to succeed in the world, you must be on the fourth industrial revolution bandwagon. Now, why do I suggest that, and I'm still belaboring this point about the science side, I'll get to the community side later. Why do I suggest that there's something bogus about that? Now, firstly, as I say, its political project for me is clear that at a time when there's such existential threats to the planet, we're being distracted into something that, if anything, would contribute to those existential threats. In other words, if technological innovation is going to lead to more industrial output, if it's going to lead to more greenhouse gases, to more human inequality, to more abuse of the environment, then we should not, if we were aware that such a thing is in the offing, we should be, as human beings, contesting such a paradigm rather than embracing it. So that's a challenge. Now, why do I also sort of decry this idea of a fourth industrial revolution? Well, firstly, if you take the first two industrial revolutions, nobody at the time called it the Industrial Revolution. When the first Industrial Revolution happened in the 18th century, and it was the shift from water, sort of natural power to steam, nobody called that industrial. It's historians 100 years later call that process an industrial revolution. Similarly with the second industrial revolution towards the end of the 19th century, which major shift towards sort of electrochemical processes, preserving foods, ability to travel across continents, etc. Nobody called it the second industrial revolution at the time. It was decades later. Now, before we're even there, some people are telling us there is an industrial revolution, and if you're not part of that, then we are going to be falling behind. As I say, we can have question time and you can debate that with me, but what it reveals is a poor historical understanding of why that typology of changes might have some relevance to us today. In other words, it turns a possible retrospective look back at changes and what it might have, how that might have helped us understand changes in the world, to a prescription where suddenly, if you don't have that, then you're going to fall behind. And I think that's scientifically dodgy. So, in other words, alongside the sort of easy targets where we can point at social Darwinism and race genetic theory and so on, there are ones that don't sound so negative. They don't, in and of themselves, sound like they could be politically or morally problematic. But I'm arguing that they are. Now, if that's the case, am I not then suggesting that scientists must somehow compromise your attention to scientific method, observation, verification, etc., because you're going to contest political battles? Now, in my talk to the MRC, I'm saying it's not as if you have a choice. Because, as I said, the real history of science itself already contains this embrace and engagement of the public. It's just that what was the public in previous generations often were elite forces that would shape the direction of science. Now, it's almost 60 years that a well-known book, and I feel I must introduce a book into this talk, which I think for some reason now they slipped off the radar, Thomas Kuhn's Structure of Scientific Revolutions, which at the time was aimed at critiquing positivism in science. The idea that science was purely a process of observation, hypothesis, observation, verification, and then you move on from that. That was the scientific practice. It was neutral, it was objective, and its evidence spoke for itself. And what he described in that book is the notion, he makes a distinction between what he called ordinary science and scientific revolutions. And he said that ordinary science is what most scientists in the world, practicing scientists, those who are, whether they're in laboratories, whether they're epidemiologists going out into communities, whether they're looking and mapping possible genomic structures, etc., etc., ordinary scientists work within a paradigm. In other words, they assume, because it's the nature of their training at the universities, at schools, etc., that there's a certain set of premises which are universally assumed to be true. And he's not saying that to say that that's false. He's saying it's a necessary part of science that you must work within a certain paradigm. And ordinary science involves the process of endlessly verifying, in some ways, what is the paradigm of our period. And that's what you do. Those of you who are still students, whatever you're going to be doing, you're going to be mostly an ordinary scientist working within the paradigm of your discipline. When you find in that process, because he articulates that when you work in that process, you will discover anomalies. There will be things where the evidence begins to contradict the premises that you work on. But the instinct of ordinary science is to say, maybe my research methodology is a bit wrong. I must refine it a bit. Maybe I looked at a case study in which the sample size was not enough. In other words, you start off on the assumption that the basic premises of the paradigm are still true, and the anomaly needs to be accommodated within that paradigm. That's why it's still called an anomaly. And when he begins to say, over time, that practice begins to throw up more and more anomalies. At some stage, the weighting of the anomalies begin to challenge the orthodoxy. And he says, even then, a revolution doesn't really happen. What needs to come along is a new perspective, a new theoretical paradigm, which has the capacity to accommodate all the anomalies and the old dogma. Let's not call it dogma. Now that's quite a challenge, that sort of picture. And he says once, like all revolutions, once a scientific revolution happens, it comes across as so obvious. Everybody now buys into it. It's like people cheer in the streets, because now the light bulbs have gone off and we can see it's this as opposed to that. Now, the one that he focuses on, and I'm going to focus on another one, but the one that he focuses on is the shift between the notion that the Earth was the center of the universe, which was the old Ptolemaic system, which was present for hundreds of years, towards the Copernican system that the sun, now center of the universe, was the center, and the Earth moved around the sun. Now, from an evidence point of view, every day you can see confirmation that we are the center, because the sun rises and the sun sets. The evidence proves the paradigm of the Ptolemaic system. Every day you confirm that. But he said what began to change was not so much some bright spark idea, but there were anomalies in the systems of astrology. In other words, something that we now hold in contempt, astrology, notions of Cancer, what your attitude, what your love life is going to be if you Virgo, etc. People who drew up astrological charts started finding that some of their predictions were increasingly becoming false, and some of their breakups of the years into semesters, into time frames, were beginning to be inexact in astrological terms. And so when the assumption came that, well, what happens if we turn this around and we start with the idea that the sun is the center and we are a planet moving around the sun? Suddenly, the astrological charts looked better. And it was only with the invention of the telescope that it became science, that it was seen as an observational proof that a revolution had happened. Now, I'm only telling that story, and many of you might be familiar with this book, because it was once upon a time a sort of textbook for people who were studying science to understand the paradigm, is that the notion of the interference of astrology, the politics and the social norms of the day on science is embedded in the nature of science. That's the point that he's trying to make and that I'm trying to make. And to imagine that somehow as a scientist you're freed from those constraints is a false one. Now, I don't want to go into others, but I mean the other well-known shift was the shift between Newtonian physics and relativity. From the idea that time and space was absolute and that we moved through space and we could quantify the time taken to move, was doctrine for Newtonian physics, and even called Newtonian physics prior to that for many, many centuries. But when the problem arose of trying to understand the speed of light at the end of the 19th century, the only way to explain why the speed of light could be constant was to say, well, then maybe space and time are not fixed. And then you invert what was fixed, and that becomes changeable, and what was supposedly changeable, the speed of light, becomes fixed. And suddenly you have a whole new explanation for the laws of physics. Now that's an example of a scientific revolution. Now, again, why do I say all this? Because when Einstein was beginning to contemplate this, and the special theory of relativity brought out and published in 1905, which was the same year of what was known as the First Russian Revolution. It was a period in Europe of tremendous political tumult, where everything was being challenged. So this geeky person who wasn't particularly good at school or mathematics was inspired by the idea that maybe nothing is constant in this world. Everything is in a state of tumult. Nothing can be taken as given. I'm not suggesting that there was a one-to-one correspondence between that and the theory, special theory of relativity, but I'm saying the social context allowed for new thoughts on what became scientific practice. So that the idea that somehow the scientist works in isolation from the social context, from the community, from the people, I'm using those two examples, is a false one. Now, what price do we pay as scientists if we continue to make that assumption? There are two things. The first thing, if you assume that you're just neutral as a scientist, then you actually open yourself up to political exploitation. It's an irony because one would think neutrality and observation is it's a defense mechanism against that world. But precisely because you present the facts, it's easy for elites to say what has come out of the scientific community is not my prejudice, it's merely fact. If the science says there's a gay gene, well, and I'm worried about my children becoming gay, and I find that I'm homophobic, then the science is in my hands to help that process. In other words, the science confirms my prejudices. It's not a challenge to the scientists to say to what extent are those prejudices embedded in the very process of observation, paradigm structuring, and theorization that I do as a scientist. And not to be aware of that intervention of society, of the public, is to be possibly the servant of political interests, rather than to pretend otherwise. Now, I'll give you finally, and before I come back to the public and what I said to the MRC. At the moment, the MRC, for those of you who don't know, the Medical Research Council, is the statutory body which is, in a sense, the custodian of most medical research and health research, particularly studies of mortality, of the burden of diseases, what are the things that kill South Africans, what are the kinds of illnesses South Africans have, etc. It also sponsors, many of you are probably getting funding from the MRC, I don't know. It also funds research at the universities and so on. And there tends to be a bit of like two parts to the MRC I've discovered since I've been there. There's the kind of epidemiological studies, the sort of statistical studies of the state of health of the nation, and that goes on. And it's what I would call ordinary science, but I'm most attracted to what those people are doing. And then there's the sexy stuff, where they either fund people who can invent new things, the innovation and stuff like that. And I'm not saying that that's wrong to do, that's also important to do. But from the boring side, the MRC's research is telling us something very important as South Africans. That currently we have 4 epidemics confronting us at the same time, health epidemics. And the reason why there are epidemics, in each one of them, our percentage of sort of world prevalence is much higher than not only global statistics, but even statistics for equivalent countries, so-called developing countries. maternal and infant mortality, TB and HIV deaths, non-communicable diseases, particularly strokes, obesity, and violence, interpersonal violence. Those four, we are the top country in the world. But if you look at them, none of them necessarily require major technological innovations to address. If you take things like maternal mortality and infant mortality, there's children getting asphyxiated in the mother's birth canal, women who are giving birth to children have excessive bleeding. None of these are about technology. They're not about the fourth industrial revolution. If you take the non-communicable diseases, people need to change their diets and exercise more and not travel around in cars but use public transport. You know, there are campaigns that can be done that are not sexy. But the MRC grapples with this because the funding is for the sexy stuff. So it sits with all this information, which is actually, as an outsider, I find fascinating. I think the public should know this, that it's solvable, it's a crisis, it's eminently solvable, it's not high-tech, it requires a change in behavior. We need campaigns, like we had with the HIV, Love Life campaigns, etc. We need those kinds of campaigns, and we need government intervention that is very low-tech. It doesn't require new economic policy. We don't have to go to the World Bank and pose new theories, etc. We must just fix very basic things. Children die of diarrhea because they don't have access to fresh water, proper clean water. Provide public services. And so probably why I was here is us, you know, when you're an outsider in an institute and you start reading all their stuff, you say, but why is this not in the public domain? You know, why are people not shouting from the rooftops? And what comes out is strongly that what makes the news is the sexy stuff. You know, if you can invent some new technological, in other words, science, this fourth industrial revolution nonsense, is being peddled, you know, that we need to be competitive in the global economy, and the only way to do that is to come up with new high-tech stuff, and our children must be sent to university, given lots of money to do all that. Again, please don't quote me as saying I'm opposed to new technological innovation. I'm not a Luddite in that sense. I am a Luddite, but not in that sense. But when the things that can be addressed are there, and they're frighteningly prevalent in our country, then we need a change of public opinion. We need to battle public opinion and show that science is not necessarily the dazzling stuff. That in that sense, every human being can embrace an approach to knowledge production and knowledge that can change things for the better. But we need to break this mythology that this is some supernatural brilliance that only few people have, and the rest of us cannot do that. Now that's the science side. Oh, the last thing I said to them, which is also important, that, and again speaking to scientists, and I suppose it's illustrated by what I was saying about Thomas Kuhn's book. As a scientist now, and sometimes you need to be honest with yourself, those who are in the training process, the biggest challenge to your own knowledge, of your own discipline, of your own science, is when you have to explain what you are doing simply. You know, science comes equipped with the language, particularly the language of mathematics and statistics and stuff like that, which, of necessity, it's the nature of the discipline. It has to find its own refinement of language, because otherwise you can't spend hours revisiting every premise. You have to assume that this particular equation works, and we're just using it. But when your child asks you, mommy or daddy, what do you do during the day? Very difficult to explain. Now that difficulty, when explaining it, is important not only for the public, but for you, the scientists. Because, and it's interesting, I used Einstein early on. I mean, the most recent one of the history of time, you know who I'm talking about. What he said was Stephen Hawking. He was the foremost science of his time, of the 20th, well, after Einstein anyway. And when he wrote A Brief History of Time, he said he found that much more difficult than actually doing the science. To explain your premises and your conclusions in accessible form was a science in and of itself, and it was more difficult. And I say that because, again, it's in the nature of our training that it's like we learn a foreign language, and then we use it, and then nobody else can understand us. But when we're asked to explain, you really have to unpack the premises. You have to re-look at the assumptions. You have to re-look at the connections you're making between variables and so on. And then you are a better scientist. So that's another reason why the issue of public engagement is not an add-on. It's about the quality of the science. You're a poor scientist if you can't explain your science to somebody who knows nothing about it. That's my challenge. Now on the public side. You see, the public is always being engaged by opinions. That's why I call it the battle for public opinion. Nature abhors a vacuum. If you are not engaging the public with your particular persuasion, the things that you've discovered, the things that you think are important, others take the place and say something else. I mean, the most obvious one in our time is the sort of big industries, big pharma, big tobacco. You know, all the evidence suggests tobacco is harmful to you. That doesn't mean that there aren't lobbyists and research agencies and NGOs and whatnot who will say that's not true. All the evidence suggests that the earth is getting warmer, that climate change is happening. People who are involved in the process of industrial production, denuding forests, spewing out greenhouse gases, they fund institutions and scientists who will say that's false, it's just natural. It happens every now and again. Don't believe it's bogus. So it's not like you can say, I can just focus on what I'm doing. That question of public opinion also means that you become complicit in the public being duped into other things, whereas you might actually have the science that can say something that is important. So again, I said it to the MRC, I'm saying it here, the act of engaging the public on the processes involved in as a scientist, the outcomes that you produce as a scientist, the verifications or the non-verifications, the anomalies or the consistencies. That's not a luxury. That needs to be built into the process of being a scientist. And what I hope to illustrate is that it's not like it's for the first time that this is happening. That's been the nature of scientific endeavor for a long time. Now, what is the public side, however? That's a minefield. We all know that. There are all sorts of agencies and people who try to convince the public in some ways. So the public is not amorphous. There are people in the public who still believe that the earth is flat. You know, and if you walk far enough, you'll fall off the edge. That's also people in the public. So the public is a contested terrain. But within the public, and sometimes if we are in the position, most of us are in this room, where you sometimes a little bit more middle class, a little bit more higher up in the social hierarchy, we often assume the public don't know, or they don't want to know. Or the public is only people who write articles in newspapers. But the public are also people who are contesting issues like livelihoods. I used to be a trade unionist. We didn't only just go on strike. We also observed processes. We were also interested in the bigger bad world of science, of technological innovation, of epidemiology, etc. And if in the process of engaging the public, you begin to have an understanding of what are the nuances and what are the networks and what are the capacities and what are the debates amongst ordinary people in the public, then you haven't done your work as a scientist. So that knowing the public is the last thing I want to say. That this public is not monolithic. Public opinion is not like a church where people just bow before the same gods. It's a contested terrain where people with different views, and you'll be surprised that when you do engage the public, if you as an institution or a university invite members of the public into spaces for the expertise that you have, you'll be surprised. They may not have the language of the mathematical expertise, but people will engage you about the implications and the assumptions that you make, even within your discipline. And I'm trying to promote it in the brief time that at the MRC, that the MRC, for those of you interested in that, needs to institutionalize the process of engaging the public. So I was saying to them, for instance, they have like 11 research units who are very focused on particular aspects of health. And I was saying, well, just roughly you take why can't you have a monthly public forum and invite members of communities, what people these days call civil society, church organizations, campaign groups, trade unions, to come there. And if you find it difficult to present your research to such a non-specialist audience, don't blame the audience that they are not sophisticated enough to understand your sophistication. Blame yourself that you haven't found a way to present this knowledge in forms that's appropriate to people who do not necessarily have the so-called language associated with this discipline. And after all, and that's probably my concluding point, after all, is all this about science and knowledge essentially about what some of us call a public good? This is about human knowledge. It's a public good. You couldn't exist as a scientist if you were not brought up by your mother, whose labor is not acknowledged in the public domain, both as a woman who delivered you, as well as somebody who fed you, bathed you, cleaned your shit, etc. And that's why you became a scientist. You know, how do you express that gratitude towards those women? You couldn't have been at school without teachers. Some of them might have been terrible, but whatever. Teachers who came there every day, walked you through all these difficult things. They're not just something part of your dim past. They're an expression that ultimately science is a public good. Now when you go there, and I say this is my final thing, then you are actually facing two challenges politically. The one is public good means you're not on sale to the market. This is not knowledge that's there to be used by the market to profit, although the market will use it to profit. In the industries associated with, as I say, genomics or biochemistry. This is a huge international global industry that patents discoveries and uses their monopoly over patent rights to withhold these from people and provide at a price. Now, it's a moral question. You know, are you comfortable with those sort of relations? That's the one thing. But public is not the same as government. Okay, despite what people think, or the state. The public are just us. In other words, you also need to see science as a public good that's independent of government and the state. You're not at the mercy of whoever. They might be the nicest people in power. It's got nothing to do with what they are. You need to keep this knowledge for the public. So, in conclusion, if we can at least, I hope I've challenged you the idea on four things. Firstly, the notion that science is a purely rigorous, objective process of gathering information, and it gets presented without any interference of politics and people and stuff is not true. Secondly, that good science is good science precisely because it has one eye on the public. It has one eye on the context in which science is produced, and often could be quite critical of the context. In fact, the periods where we had scientific revolutions were precisely ones where the anomalies began to be emerging in the laboratories, in the scientific investigations. And you couldn't explain the anomalies anymore without resorting to new scientific development, new scientific paradigms. And those new scientific paradigms require new public engagements. And lastly, that the public is not monolithic, that the rough and tumble of social movements, church organizations, campaign groups, political, all that stuff, that's a knowledge you also need to have as a scientist so that you can understand this public good that you're the custodian of, for whom you need to be making that public good as public as possible. without compromising on the endeavor and the effort you put to actually getting the results. You can't cook the results, but without compromising on that, you need to make the process and the outcomes publicly available. Thank you. That was what I told you.